So on that page, we have a summary, those 2 pages, of the words used to solve or understand expressions. And remember, as far as notes are concerned, I expect them to be personal, but if they're not legible to me, when I go to look at them, I'm not going to be able to give you full credit. So be in control of your wrists and your handwriting, folks. All right, so starting with example 1, again, this continues to be relatively simple, and it's a good warm-up for our brains after we've all been, busy all summer doing fun things. Starting with example 1, they have us being reminded of less than, greater than, and equal to symbols being utilized to analyze whether or not something is true or not, right? So for A, we get to choose which one of these we're going to plug in. And I know some of this is utterly simple, but please, please, please follow along and fill everything in. Obviously, in order to ascertain which item you're going to use, you have to solve the left and solve the right. I would say everybody probably had no problem coming up with the equal sign, right? And letter B, a little bit more work, but really not much, nothing you can't do. Comparing the quotient of 27 and 3 with the sum of 3 squared and 2. Notice I used all those words that you could see here in your definitions, and that's how you're going to see things phrased. So it looks like 9 compared to 11, and we're going to end up with a less than symbol. They didn't include less than or equal to, greater than or equal to. You guys know how to use those, and those will come up soon. Okay, please look at the bottom of page 7. To simplify an expression, you replace it with the simplest or most common item having the same value. Erin, how old are you? 16. 16. So she is 7 times 2 plus 2? I wouldn't do that, right? And she didn't answer me that way because she's going to use the simplest terms. Okay, so Erin is 16 years old. So this is simplified. What did I say? 7 times 2 plus 2. This is not simplified. Whenever you can, get it down to the simplest terms if there's anything more you can do. In the same way, this is not simple. Okay? It's still not simple. She's not going to walk around saying she's 14 plus 2. All right? Now, if you wouldn't mind, please turn with me to page 8. We are moving on up, page 8. Today I didn't have you copy the gray, but do realize that if it's in gray or if it's in boxes or if it's bolded, it is stuff you're going to see. Okay? And in the interest of time, I certainly don't spend every moment on every single word in here. Simplifying expressions. So substituting, that is putting in something else that is the same. I mean, it's almost like thinking you simplify something, but substituting is plugging in something that means the same thing. And I'll show you an example of that. Some examples of that anyway. Take a look at the order of operations. Please excuse my dear Aunt Sally. That's up yonder over there. You can also see it on page 8. You guys were introduced to this probably back in junior high, maybe even somewhat in 6th grade. Order of operations is critical. And if you don't follow it, you will continue to run into incorrect answers if there's multiplication with addition or division with addition, that kind of thing. Okay. Another item of note, you're not going to see this or this very often to indicate multiplication. You're not going to see that so much anymore. Okay, so instead of me writing 6 times y, you'll see me write 6y, which means multiply. Instead of writing 3 times 2 plus 1, maybe I'll even make it 2 plus x. Make it 2 plus x. You'll see me write 3 parentheses 2 plus x. Okay? The dot and the x no longer are going to be used much in your textbooks. It's going to be assumed that you know letters next to each other or numbers next to each other mean multiply. And if they did do numbers next to each other, they would either go 3, 6, well, that's pretty much, I can't really think of any other way they would do it. Yeah, that's pretty much all you would see in this textbook anyway. Okay? So this is how you're going to see multiplication for the rest of your math career. In calculus book, it's the same thing. All right. So guys, let's go ahead and practice these again, seriously. So any problems with example 1 before I move on? About 6 or 7 more minutes, guys. Pretty easy lesson today. Example 2. We're going to go ahead and go through simplifying items A, B, and C. So I'm going to start with A. 2 times 5 minus 6 divided by 3. Based on Aunt Sally's rule, you do any parentheses first, followed by exponents, followed by multiplication or division, and or division from left to right, which means I'm going to do this and that. After having that, you end up with your final answer of 8. Okay? Regardless of the fact that there's not parentheses, you still need to consider that in case you always have to ask yourself that question. B is 2 brackets 4 plus the sum of 2 cubed, or the difference of 2 cubed and 1, close brackets, close braces. Okay, we do have some symbols that we have to play with. And you always do the innermost one first if there are multiple. We have parentheses and we have the braces. So 2 times 2 times 2, we're going to do that exponent, which is 8. Am I right? Remember, it's not 2 times 3, it's 2 times 2 times 2, which is 8. 8 minus 1, you guys are old enough to be able to do that, I think, in your head. Leaving me with this. Okay? Still braces being involved. We're not going to multiply 2 times 4. We're going to handle this. 11. And that brace next to the 2 means multiply. Okay, there's answer for letter B. And finally, C. C may seem more tricky, but following the same steps and going slow as snot, okay, to make sure that you don't make any errors. And go back and review it, guys, because I get incorrect answers still. It seems like every year, because we kind of forget that you got to be really, really careful. So it's 5 squared minus the quotient of the sum of 1 and 5 and 2. You may not realize it, but this is a symbol that you have to deal with. Okay? So we are going to combine the 1 and 5, and we can square our 5 squared, because that can be done as well. It's a separate item. 25 minus the quotient, which becomes 25 minus 3. Same answer. I hate it when they do that. 22. Couldn't they have come up with a different problem? Can I move on from example 2? Yeah. Yes? Okay. Again, 3 more definitions for you. Variable values and algebraic expression. I promise you, you're going to see all these bolded words used in tests and quizzes. By the way, I already have our first quiz on the books. I can tell you when that's going to be when I'm done with the lesson. Variable, domain, replacement set, values, algebraic expression, evaluating, which is the same as finding the value of. So here we go. Example 3. Evaluate if, which means they tell you they want you to use this value. X is 4, y is 3. This means plug in those values and solve wherever you find those letters. Okay, plug in and solve wherever those variables are found. So it says to me, evaluate if x is 4 and y is 3. Here's A. 3x, the product of 3 and x divided by the difference of x squared and 8. I'm going to go horizontally here. Tell me what the value is for x, John.
4.
3 times 4. Let's camp on that x. The product of 3 and 4 divided by, what's x squared, Ash?
X squared, that would have been, I already got it. 6 squared would be 4 squared, which would be 6.
She's right. So we solved by plugging in. We plugged in. Now we're going to continue by simplifying. 12 divided by 8, which reduces to 3/2. And just like Jazz said, if you write 1.5, that's fine. And notice they even tell you that in the book. All right. B is a little bit more tricky, but we're going to still use the same fundamentals. X squared times y minus x y squared. And this is where I find people making mistakes. When there's no numeric coefficients and all you have is variables, it's really easy to trick up. So first let's find x squared, because in that, please excuse my dear Aunt Sally, after symbols of exclusion, your exponents come next anyway. So x squared, let's square that x real quick. So that's 16, right? 16 times, and if I wanted to be super slow about it, I can go like this. Y squared, which is 9. Okay, the product of 16 and y minus the product of 9 and x. I'm sure most of you would do it all in one fell swoop. And for the most part, that's fine as long as you don't make an error. Since y is 3, I'm going to do 16 and 3. Wait. I screwed up here. Yes, no, I didn't. 16 and 3 for y. See, I was about to make a mistake. Minus 4 and 9. So you should have come up with 48 minus 36. Book tells us it's 12. Doesn't take a rocket scientist. These are the ones I find easiest to screw up. Absolute value. They give you a small definition there in the bottom. And the way I told it to the other classes is it's the distance for that number from itself to 0. Okay, so for example, the absolute value of -3 on a number line is the amount of spaces it would take the -3 to walk back to the origin. 1, 2, 3. So the answer to the absolute value is 3. The more advanced definition is on the bottom of page 9. Okay? The more advanced definition is on the bottom of page 9. And if there's anything within that that's confusing, that bottom piece says the absolute value of A, so let's call this A, is, well, it's just A, as long as this number is greater than 0. If it's 0, then it's 0. The last bit in my book shows the absolute value of A is the opposite of A. In other words, if it's a negative, it's a positive. The answer will always be a positive answer from what comes out of that absolute value symbol. Which is where we lead to example 4, last thing. Example 4, again, evaluate 10 times the absolute value of x added to the absolute value of y. So that I don't think my absolute value symbols are ones, I make them a little bit big. You do whatever works for you though. So I'm going to plug in my values. X is 3, y is -2. 10 times x is 30. Added to, what's the absolute value of -2, class? 2. So 32 should be your final answer there. Now, this is simple. Please go down though with me really quick to number 22, the bottommost section of the orals. So we're kind of going just a little ways down the page, oral 22. Okay, so I'm just going to do these really quickly with you. Just a couple. So we're evaluating still, and they're saying x is 3, y is -2. Isn't that convenient? All right, 22 says this. The absolute value of x minus the absolute value of y. Okay, x is 3 minus the absolute value of -2 is 2. Make sure you don't accidentally keep this a negative because it's preceded by a negative. I know that might seem a little strange, but I've seen people accidentally say 3 minus a -2 and add them together. Okay? Don't make that error. There's 22. And 23, here's one final one. Please copy it with me. I want to make sure you guys feel comfortable. X squared's absolute value, or x's absolute value squared, added to y's absolute value squared. Here's another opportunity for you to potentially make a mistake. Again, we're squaring, so it makes things positive anyway, but I've seen somehow things get flipped. So let's take our 3. 3's absolute value is 3. 3 squared is 9. That should be that little deal. 9. Added to, y is a -2. Y's absolute value is 2. 2 squared is 4. Don't let the ease of these problems cause you to make a simple error in your calculation. Also be really careful on your calculators. If you type in, hang on a minute. Look at number 8. Still in the oral. It's 8 minus 2 in parentheses times 3. Does everybody see that? Don't type into your calculators 8 minus 2 times 3. Because that is not going to solve your 8 minus 2 item.
It's going to solve 3 times 2 first.
You're going to get that. Okay? It used the order of operations, and since you did not plug in any parentheses, you will not get the correct answer. However, my calculator has parentheses, so you can potentially, I know this is a simple one, 8 minus 2 parentheses times 3. If you do bracket or brace it, you'll get the right answer. Okay, so be very mindful of those things. Your calculator is looking for you to tell it how you want to solve. Okay?